2 and 2. So what did we decide on? 1 and 4 or 2 and 2? 2 and 2. Factors of 9. Or 3 and 3. And we can indeed try 3 and 3 first. And if we multiply this out, 2x times 3 would be x, positive 6x. 3 times 2x would be positive 6x also. 6x plus 6x is 12x, giving us 2x plus 3 times 2x plus 3. Now, we could rewrite this as 2x plus 3 squared because they are the exact same. Because 2x plus 3 and 2x plus 3 are the same, so we could rewrite it as 2x plus 3 squared. Either one will work. Either one of these will work. You don't need both, but you need to have at least one of them. It's going to be similar to these two here. There is one of them on the homework or on the review sheet. It's just a higher power. Let's look at number 3, a squared plus 4a plus 4. There is no greatest common factor between these three terms, mainly because the number in front of a squared is 1, and our third term does not have an a, so no greatest common factor. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. Here, third term is positive, so the signs are the same. Match sign middle term, they're both positive. Now we need to find the factors of the first and third term. Well, our factors of a squared are a and a. Now we need to find the factors of 4. 2 and 2.
Can we rewrite this as just a plus 2 squared?
Yes. A times 2 is 2a. 2 times a is 2a, giving us 4a, which is the middle term we wanted. So a plus 2 times a plus 2 is the correct answer. Or we could rewrite it as a plus 2 squared. Questions on this one here? We're ready for the next one. Number 4, x squared plus 6x minus 27. Again, there is no greatest common factor between these three terms, so we'll have our two sets of parentheses with 3 spaces. Three does go into 6 and 27, but since there's not a number in front of x squared, we can't factor it out. Now, since the third term is negative, our signs are opposite. One's going to be positive, one's going to be negative. Factors of x squared are x and x. Now, factors of 27 are 1 and 27, 3 and 9. And that's it. There's only 2 sets of factors for this one here. So we can do 3 and 9 first. And we can check this here. X times negative 9 would be negative 9x. 3 times x would be positive 3x. Negative 9x plus 3x is negative 6x. Yes, since it is the correct number but wrong signs, we just need to flip the signs. And if we check this here, x times 9 is now positive 9x. Negative 3 times x is negative 3x. And 9x minus 3x would give us a positive. All right, guys, let's focus in. So we get this here. Questions on number 4 before we look at number 5. 8x squared plus 6x minus 27. Well, again, there is no greatest common factor. So I have 2 sets of parentheses with 3 spaces. Since the third term is negative, our signs are opposite. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. So our factors of 8, 1 and 8, 2 and 4. Now we still do have the x and x, but since that's the only factors of x squared, we'll put them in first. Now we do need to pick between 1 and 8 and 2 and 4. Which one do we want to try first? 2 and 4. Factors of 27. And 3. And at this point here, we can check this. 2x times negative 9 would be negative 18x. 3 times 4x would be plus 12x. Negative 18x plus 12x is negative 6x. So we just need to switch the signs. We got the correct number but wrong sign. So we need to switch the signs, make the first one negative, the second one positive. And if we check this one again, 2x times 9 is now positive 18x. Negative 3 times 4x is negative 12x, giving us a positive 6x. So these are the correct factors. No, wait. Questions on 4 or 5 before? Yep, that's it. That's all we're doing. Because it's all in preparation for chapter 7, the next chapter that we're going to cover, rational equations. Part of rational equations we'll have to factor to be able to solve. So we go over this again just to reiterate it and get back into the swing of things. Number 6, 64x squared minus 1 is, well, it is a difference. Is 64 a perfect square? What times itself is 64?
8x.
As 8 times 8 would indeed be 64. X times x would give us x squared. So 8x times 8x would indeed give us 64x squared. What times itself is 1? 1. So this is indeed a difference of perfect squares. So I'll have 2 sets of parentheses with 3 spaces. Our signs are going to be opposite. One's going to be plus, one is going to be minus. We'd have 8x, 1 and 1. We don't have to do the parentheses 8x close parentheses squared minus parentheses 1 close parentheses squared. But we do need the 8x plus 1, 8x minus 1. This step here just helps us get it what we need to plug in each spot. And on 6 and 7, if there is a greatest common factor on these, we need to factor it out. But on number 6, there was no greatest common factor between 64x squared and 1. Number 7, a cubed and 1 don't have a greatest common factor, so we can't factor anything out on these here. Yes?
Do you do the, what are they called? The college classes in the evening?
Not in the evening, but we do have college algebra first hour.
Because I go to HEC and I want to do
And you can work it out, I think, then, because you can do NTC in the morning or afternoon.
Because I have football in the afternoon, and that's why
we can probably work it out. Yes. Now, when we look at this next one, a cubed plus 1. Now, the reason that we're going to do cubed root is because a to the third tells us that this is either going to be a sum or difference of two cubes. Now, the plus in the middle tells us most likely it's going to be a sum, and we just need to take the cubed roots to verify this. Well, the cubed root of a to the third is, well, just a. Cubed root of 1 is 1. Because when we take the cubed root of 1, we're trying to see what times itself. 3 times is 1. Well, that's just 1. So we have a sum of 2 cubes. So this is our parentheses with 3 spots and parentheses with 5. Now our signs are going to be the same. Opposite always end on a positive note. So we're talking about sum, so the same would be plus. Opposite would be minus. Always end on a positive note would be plus. Now our first set of terms we're plugging in this case would be a. So our first spot would be a. And the bigger one we would have a squared. A to the first. And then no a term. In our other spot we have our 1. And in the smaller one we would just have 1. We would not put a 1 with our a squared, but in the middle we would have 1 to the first. And in the last one we would have 1 squared. Questions on how we set this up? Questions? Where at?
I just don't understand how you know where to put everything and why there's an 8 and one is only. I just don't get it.
Oh, let's not use a and b. Let's say x cubed plus y cubed is the sum of 2 cubes. Factors 2. This here. That's just definition. And we take the cubed root of these two terms to find out what x and y is itself. So for us here, x is just a, y is our 1. So it's just xy. In the bigger one, we have squared first, no x term.
Let me write that down.
Because our signs, as we've gone through this, are going to be the same, because that shouldn't be plus. That should be minus. Opposite always end on a positive note. Our first term, x, x squared, x, no x. Well, x is a. Here we have our a squared, a to the first, no a term. Our other term, huh?
What happens with the signs? Anything? Just
Same, opposite, always ended on a positive note. Same, opposite, always end on a positive note. Now for our 1, didn't necessarily need the parentheses around it. We have 1. Inside here, there is no 1 with our first term being squared. The middle is 1 to the first, and the last one is 1
that makes a lot more
squared.
sense. I mean, I kind of got it, but I didn't.
Now, same setup we have at this point. We just need to simplify a few things. The a plus 1 is just going to stay a plus 1. We will square this first term. A times a is just a squared. Minus a times 1 is a, plus 1 squared is 1. So we have a plus 1 times a squared minus a plus 1. Let's look at number 8 next. 8x squared minus 72. So we have two things being subtracted. X squared tells us that there's a good chance this is a difference of two squares. But again, it's still going to be good to look for a greatest common factor. Is there a greatest common factor between 8x squared and 72?
Yeah. No.
Because if there isn't one, our next step is to see what times itself is 8.
Yeah, there's not. Hey, does go into 72, right? No way. It's not. Well, no. I did that with my fingers. But not going down all the way.
Nobody learned the way I did it.
What?
Minus the letter, or minus the number, and then go up.
I got half what you.
So like 3 would be like 2, 3, 4, 5, 6.
Yeah, it's all.
I don't know, because I can't do this.
So 8x squared minus 72, there is a greatest common factor of 8. 8 will go into both terms, so we need to factor it out first. Now that leaves us with x squared minus 9. X squared is a perfect square. It would be x and x. And what times itself is 9? 3. Since it is a difference of perfect squares, our signs are opposite. And we said what times itself is x squared? And x. What times itself is 9? So that's it. Because our definition of difference of perfect squares is a squared minus b squared is a plus b times a minus b. A in our case is x, b in our case is 3. Let's look at number 9. Is there a greatest common factor between 25x squared, 10x, and 3? Well, 25x squared and 10, yes, they have a greatest common factor of 5, but 3 does not. So there is not a greatest common factor with these here. So we'll have our two sets of parentheses with 3 spaces. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. So here the signs are going to be opposite. One's going to be positive, one's going to be negative. Now we need to find the factors of the first and third terms. 1 and 25, and 5 and 5. Now, since the factors of 3, there's only one set, 1 and 3, we might as well plug those in. 25x squared, well, we will have x and x. Now we just need to determine if we're going to use 1 and 25 or 5 and 5. 5 and 5. Questions on how we got this set up? At this point here, we can check to see if we've got the correct setup. 5x times negative 3 is negative 15x. 1 times 5x is positive 5x, so plus 5x. And negative 15x plus 5x is negative 10x. So 5x plus 1 times 5x minus 3 are the correct set of factors. Let's look at number 10. 36x squared plus 49. Is 36x squared a perfect square?
No. Yes.
6 times 6 would give us 36. X times x would give us x squared. So 36x squared is a perfect square. What times itself is 49?
7.
7 times 7. Is this a difference?
Yeah. No.
We don't have a sum of perfect squares. This is actually not.
Not factorable.
Not factorable. That's actually as simplified as it gets.
Okay. So there's a plus right there, and it's like a square, both squared. It's not factorable.
That's not factor. We don't have a formula or a way to factor the sum of perfect squares. We only have the difference of perfect squares. Because we do have the sum of two cubes, we just don't have the sum of two squares. Let's look at number 11. 49x to the fourth plus 343x cubed plus 7x squared. Is there a greatest common factor between these three terms? Well, our x to the fourth, x cubed, and x squared tells us there is indeed a greatest common factor of x squared. Well, 49 and 7 do have a greatest common factor of 7. But the other question is 343 divisible by 7?
Is it? I'm going to say it is. Got it.
Oh my
Got him.
Now, if we factor 7x squared out of 49x squared, 49 divided by 7 would be 7. Our x to the fourth divided by x squared would be x squared. Our 343 divided by 7 would be 49. And if we remove x squared from x cubed, we have x. And if we factor 7x squared out of 7x squared, we're left with 1. Because whenever something factors out completely, it reduces to 1. So what we have left, or what we have at this point, is 7x squared times 7x squared plus 49x plus 1. Now there's a pretty good chance that 7 and 1, factors of 7 and 1, is not going to get us to 49. Now we can check that with our square root of b squared minus 4 times a times c.
Also, we're just going to leave it as it is.
So this here is the answer in simplest form. There will be some on the test where you just factor out a greatest common factor and you're done. But there's not going to be one like 10 where it doesn't factor at all. There will be either a greatest common factor or we're going to reduce it to two sets of parentheses. Any other questions on number 11? Let's look at number 12. Is there a greatest common factor between 216 and 2,197?
I'm going to say 8.
21,
I'm going to say 8.
21, 97.
Dang it. What's going on? I got
Now, when we look at the problem here, we do have an x to the third term. So there's a good chance this is a difference of two cubes. So one thing we can try doing is taking the cubed root of 2,197. So it shows that we can take the cubed root, 2,197, x to the third, which would be 13x. Now we need to take cubed root of 216. Cubed root of 216 is 6. So what that tells us is that this is a difference of two cubes. So we'll have our two sets of parentheses. The first one will have 3 spaces. The second will have 5.
May I have your attention, please? Students, please remember, if you did not ride the bus and if they did not come and pick you up, they will not be taking you home. So if they did not come and pick you up this morning, they will not be taking you home this afternoon.
Okay, they're not taking us home.
Thank you.
I'll ride my bus. For real, dude. I'm gonna have to text people home. For real.
So our signs are going to be the same, opposite, always end on a positive note. So since we had a subtraction first, our first sign will be subtraction. Opposite will be plus, end on a positive note,
Oh, so
or
they're
plus.
So the sign in the middle only affects the first two signs.
Yep. Since we started off with subtraction, our first one would be subtraction. Flip it, plus, last one's plus. Now the next thing we're going to do is plug in our first term. So in the smaller set of parentheses, it'll be 13x. In the bigger one, the first, we're going to have our 13x being squared to the first power, and then we won't have anything in the third spot. Questions on this so far? Our other term is 6. We won't have anything in with our 13x squared. In the middle spot, we will have 6 to the first. And our last one is going to be 6 squared.
Wait, so which one's, okay. So X, 6 is Y?
Mm-hmm.
So like, let's say, the two what max, like, how it goes beforehand.
Yes,
Always be X.
that'll always be first. Yep. Yeah, the only thing different from the one we wrote down is just the signs, but the signs will always be the same. Opposite always end on a positive note. Now, we do need to simplify down some. 13x minus 6 for our first set of parentheses is just going to be 13x minus 6. Now, we need to take 13x squared. We're multiplying 13x by 13x. Well, 13 times 13 is 169.
How you know that?
And our x times x is x squared plus 13 times 6 is x plus our 6 squared is 36.
At least you were honest. Is that it?
Oh, yeah, I should be able to.
I was like, you're so sure.
And that's it. Questions on number 12? Let's look at number 13. 375a cubed plus 192b cubed. Well, this is either a sum or difference of perfect cubes. And the kind of giveaway fact is our a cubed and b cubed. But again, we still need to look for a greatest common factor if there is one.
So it's plus though. It's if they both cube out, it's plus and it won't be factor.
Squared, yes. Cubed, no. Because we can have the sum of 2 cubes. We can't have the sum of 2 squares. Now, a cubed and b cubed, there's not a greatest common factor between those two variables. 375, 192. Well, we can take the cubed root.
6.
375, we get a So, is there a number that will go into 375 and 192?
We gotta do that like that in the 3 separate whatevers.
Well, 375 is not divisible by 2 because it doesn't end in it. It's not an even number.
So it's 3.
And if we divide 192 by 3, we get 64. So that does tell us there is a greatest common factor of 3. So that leaves us with 3 times 125a cubed plus 64b cubed. Now we can look for another greatest common factor, but actually there's not one. 125 and 64 do not have any other greatest common factors. And we can